If you watched the 103 video, you know that was kind of long, but you can always skip through. Let's jump in and get started with 106, inequalities. I solved a lot of these in class with some of you, in the help lab with others, so thank you. I will still continue to do that. Just think of this as an additional support, a thing to review, share, talk about. Okay, so here's our distribution. That's great, right? It's kind of nice to see where everybody is in the class. In college, they always used to do this on an overhead projector. Ha! If you know what those are. Remember, if you are red or orange, please try those retakes. Reach out to me, submit test corrections, and if you're still continuing to score there, that's okay. Let's try to get in at the root of the problem, or maybe look for some resources like calculators and things that will help bridge your understanding. Jumping in. View and copy. Inequalities. Okay, I solved that one. Let's solve this one. All right, so some of the things I'll try to do is be faster. I wanted you to notice in these answers, the variable is on the left-hand side. And as we discussed in class, or you might have heard before, hey, you can just shade whichever way the arrow is pointing. This is true when the variable is on the left-hand side. So let's go ahead and do a nice algebraic trick to organize our inequality that way. I'm just going to bring the variable to the left-hand side. So I'm going to add 4x to both sides. Okay? Now I'll have 4x minus 6 is greater than or equal to, because that's how we read the symbol. We read from left to right. If it's the big mouth first, you say is greater than, if the line's underneath, or equal to. Then you have 10. The minus 4 plus 4, it cancels, but again, it equals 0. We're now going to add 6 to both sides. It cancels, it equals 0. We have 4x is greater than 16. And then finally, we divide. Now notice we're dividing by positive 4, or regular 4. In that case, we leave it alone. Boop, boop. You can use a calculator. Okay. Division and multiplication and inequalities, when you're solving, you only flip if you're dividing by a negative or if you're multiplying by a negative. Otherwise, if it's a positive number, it's fine. And think of it, because the negative means we've actually call it the opposite. So again, 4, this is the opposite of 4. And you can think about that on a number line. If this is 0, and here we're at positive 4, well, where's the opposite of 4? Negative 4. You can think of it as equal distance from 0, but on the other side. Lots of ways to think of it. But remember, if it's a negative, you want to flip-flop if you're dividing or multiplying, not if you're adding or subtracting. You could easily subtract from both sides and not flip it. Okay, so common misconceptions just to kind of keep in mind. Here we go. Let's go on to question 2. Solve for x. Ooh, it says no solution. Maybe we'll do more than one here. First things first, the distributive property. We get 5 times x, 5x. See right here? 5 times 1, 5, is less than or equal to 5x plus 3. We want to get the variables on one side. That's standard practice. Try to get them to one side. So let's subtract 5x from both sides. Let's try to bring it over here to the left like we talked about. All right, well, what? 5x minus x, it equals 0. So I'm just going to write it. It does cancel. Is less than or equal to 5x minus 5x. Solve for x. Well, the x is gone. No solution. Let's keep going. 0 plus 5 is just 5. Less than or equal to 3. 5 less than or equal to 3 is not true. And that's why there's no solution. So when your variables cancel out, disappear, get subtracted, right? Something happens and you're solving correctly. It wasn't a mistake. Your final statement, your simplest form, is a non-true statement. there's no solution. It means there's absolutely nothing x could equal to make that inequality true. No value of x will ever make that inequality statement true. So there's no solution. It's not because it disappears that there's no solution. It's because the final thing, 5 is less than or equal to 3, that's false. False. Okay. Let me zoom out. We're good. Let's go look at another one. I was looking for my all real numbers. I was looking for my Dwight bag. Okay, let's distribute. Oh, I made a mistake when I worked with a student. I distributed this and I rewrote it as 3n plus 6 greater than or equal to 3n plus 8, but I did something wrong. 3 times 6 is 18. I have to distribute it across both terms. So now we're good to go. Okay, common, I make mistakes. We'll all make mistakes. Again, let's try to get the variable onto the left-hand side. So we will subtract 3n. Uh-oh. Psh. We're left with 18, greater than or equal to 8. Is this true? If that's true, then no matter what n will be, it'll be all real numbers. Any value we put in for that variable will keep that statement true. That inequality will be true no matter what we throw at it. So that's how no solution in all real numbers, those are the situations that you might see them arise, special cases. All right, thanks for watching. Let's keep going. This one's going to be fairly quick. This is a compound inequality. Inside minus 15, I want a alone. You always want to isolate the variable. So if there's minus 15, I'm going to add 15. But I need to add 15 over here, because see that inequality symbol? And I need to add 15 over here. So whatever your numbers are, that's what's going to happen. So I'm going to come over here. A is in the middle. It's going to be greater than negative 5 plus 15, 10. A is in the middle. It's going to be less than 2 plus 15, 17. You can use a calculator if you're uncomfortable combining positive and negative numbers. By all means, use what resource helps you learn the math. Okay? Next, we need to remember we're graphing. Look how A is in between these two numbers. So it's not going to be something with a gap. That's not going to be it, because that would be an or compound inequality, or, because it can't both be true. Remember, or one or the other, or both. So they could both be true, but in this case they can't. So it can't be an and. An and is both situations have to be true. So A has to be trapped between 10 and 17. So we know it's going to be one of the three that are shaded between things. We also know the lower bound is going to be 10 and the upper bound is going to be 17. So it's now just between these two graphs. We have to then decide, is it a closed circle or an open circle? And obviously the answer is highlighted that it's an open circle. And the reason for that is this symbol. That is a strict inequality. Therefore, it's an open circle. It does not include 10. And if you remember at that Ferris wheel, this is for older than 10 kids can ride. Older than 10 kids can ride. If it was 10 or older, it would be a closed dot inequality because we would include 10. But in our case, it's not. Okay, let's keep going. 4. What is the solution to the compound inequality in interval notation? Okay, that's a freebie. Let's look at this one. All right, so there's the answer. You can, I got the answer. It's my question. Let's talk about the strategy. Notice there's an or. That's a good sign that it's probably going to be one of the ones with an or, but not always. They might be tricking you because that's what math curriculum writers like to do sometimes. So at the end of solving, you might end up where the x is greater than and less than something, so it's a closed interval. It's got a lower bound and an upper bound. Whereas this one, the answer says that one side's going to go to negative infinity, the other side's going to go to positive infinity, and let's find out how they got there. I'm going to start with this side first. It just looks easier. There's no distributive property. It's not that much easier, but it probably saves me one step. So I'm going to add 4 to both sides, right? Plus 4, because it's the opposite of negative 4. And I'll rewrite it over here. So 2x minus 4 plus 4 gets rid of the 4. That's the whole reason we're doing it. We picked that to do it. We wanted that to happen. Negative 10 plus 4, negative 6. Starting to think about negatives, I like to think in terms of money. If I owe you $10, negative 10 over here, and I give you 4, we're not even. I still owe you negative 6. Play with them. Negatives are important to understand just because of the world around us. Next, 2, we're dividing, right? 2x, the flow of solving. We don't flip because 2 is not negative. We didn't divide by a negative. We didn't multiply by a negative. It's okay that this side is negative. Aha. So some cool things happen here. We already know if I was going to write interval notation just on this side, the x is smaller than negative 3. So the left side, the left part of the parenthesis is going to go to negative infinity. Nothing's stopping it right now. It might when we solve that. We'll find out. Comma, but the upper bound, the right-hand bound in this particular one is including, because of that equal to sign right there, right? Including, so we square bracket it and we stop it at negative 3. So that's the interval for that portion. So let's go solve this one. 4x, 4 times the quantity x plus 1, we're going to distribute. We'll end up with 4x plus 4. All I did was multiply each term in the parenthesis by 4. 4 times x is 4x. 4 times 1 is 4. I'm now going to subtract 4 from both sides. Subtracting is fine. I don't switch the inequality. I'm just trying to get x alone, all by itself. No friends, no family, nothing. Divide. Get my way. We're still fine. We don't flip it. We didn't divide or multiply by a negative. X greater than negative 2. Now I think about this. Hey, x is greater than negative 2. Strictly greater than negative 2, so it's getting bigger. This might not help you with interval notation because you see the x over there and you think infinity, comma, negative 2. No, because x is going to positive infinity. So think the largest it can make is going to be our right-hand bound. So that will be our right side. And the lowest it'll go in this dark blue will be negative 2. But see how it's not equal? We're not including negative 2, so we use a parenthesis. Take your time, use notes, think about it. But there you go. Last question. Amy. We did Amy in class. I did Emily and Mary, so I want it with another student. So let's do Matt. I haven't solved Matt. See, remember, I like math. Oh, well, there we go. We know it's 10. I'm sorry, I was trying not to give it away. Why is it not zooming for me? There we go. Okay, so we know what it is. Let's just take a look at the answers for a second. I wonder if you could just kind of guess on this one. Let's read it. Matt is 5 years older than twice his cousin Andy's age. The sum of their ages is less than 35. Let X represent Andy's age, which inequality represents Andy's possible age. All right, so I am a bad math student, and often I will just jump in and start solving without reading the whole problem, but don't be like me. Be a good math student. Read the whole problem, think about it, and then start to set it up. Matt is 5 years older. So in my brain, I hear 5 plus, right? Twice Andy. Whoa, X. They told us to put X, so 2 times X. The sum, hey, that means plus, of their ages. So that's going to be Matt, the sum of Matt, oops, pretend that's a T, plus Andy, I'm going to write out the names so you can kind of see where the math is coming from, is less than. We like that. 35. So Matt and Andy, their ages together have to be less than 35. Notice that doesn't say less than or equal to. That is the exact phrase for that symbol. The exact phrase for that symbol, okay? So we can already eliminate this answer choice and this answer choice. The zeros are coming from, again, we're talking about age. We can't be negative. We cannot be negative. So the zeros are just there to keep our number sense, forward. That's the point. We gotta be comfortable with the numbers around us. Sorry. Ooh, getting dehydrated. Okay, so now Andy, let Andy be X. I just read the problem, so I didn't really do a whole lot of thinking there. Let X represent Andy's age. Okay, X plus Matt. I did the thinking already. Twice his age, well, that's 2 times X. Twice is always double. Twice 2, 2 times, 2 times. 2 times what? 2 times Andy's age. Well, Andy's age is X, so 2 times X. 5 years older would be like 5 plus. Now we do our algebra always. We'd end up with 5 plus 3x. The algebra there was combining like terms. We have 2x plus 1x. You deal with the coefficients. So 2 plus 1 is 3. We have 3 x's. There often is going to be invisible ones. Lots of places, invisible ones. In Unit 2, there'll be an invisible 2. And we'll talk about that. No invisible numbers. Now I'm just solving. I'm on the solving train. They cancel. They equal 0. The reason I bring that up is sometimes we say phrases like that and it becomes confusing later on. What does canceling mean? Canceling out. What? How does that even work? We can just randomly cancel stuff? No. We need to have a mathematical process behind it. Otherwise, it's going to be chaos and math doesn't represent anything. 30 divided by 3 is 10. Okay, thank you for watching. Again, let me know if these are helpful, if you want me just to focus, stop rambling, or the rambling is helpful, or you have any type of feedback. I love growing as a teacher and as a human, so feel free to let me know, good, bad, or you don't say anything, and in that case, that's also a form of feedback. Thanks again. I'm always here. Call, text, email, here to support your journey, but please just try the thinking.